All right. Thanks so much, Kelsey. All right. So I'll speak quickly through a few different highlights when it comes to heliophysics and space weather and our integration within Artemis and some of the Moon and Mars work. Overall, definitely appreciate the time today to share a lot of really exciting things going on that have been happening and are coming up in the next couple of years. Very quickly, my name is Jamie Favors. I'm within the Heliophysics division at NASA headquarters. I'm the deputy lead on our space weather program, as well as a program executive on a few different missions, Hermes being one of those, and we'll talk about that today. Next chart, please. And that's exactly where we will start, is with Hermes. This will end up being our first science payload going on Gateway, coming from NASA. And actually, I think if you look at our documentation, we see the 001 number on some of our payload documents. I think we'll take credit for being that first payload going on Gateway. But we have really strong international collaborations going on as well here. So Hermes as a payload is four different instruments that will integrate as a single package, as an external payload going on this first launch of Gateway. For those two modules, you see an artist rendition of those two modules together orbiting the moon on the top of this chart. Though I didn't put an arrow in, if you notice on the forward module, there's a small little box that's pretty nondescript here. That's actually Hermes. We'll be on the bottom side of that forward module or halo. Here we'll be making our measurements. We're an in situ package. So there's no remote sensing on this one, but measuring particle and fields around the moon from this vantage point here. For Hermes, as far as where we are status-wise, we're very close to fully entering our payload INT phase to do that kind of final work there. Then we'll go into a storage phase for the mission, and that'll be in preparation for, at this point, no earlier than October 25 launch date for these first two modules, or CMV, co-manifested vehicles for Gateway. And as I mentioned just a moment ago, we are just one of a few that are going on this first launch. There's actually three of us, two external, Hermes being one of those. Ursa, or provided by the Europeans, will be another external payload. And then IDA is an internal payload coming from JAXA. That'll be inside the Halo module there. What's really interesting with these first three payloads is we're actually doing very complementary measurements of each other to kind of give this full spectrum to understand the space radiation environment out around the moon. So those data sets really are compatible with each other. So these teams together are actually working on science objectives and having lots of good conversations there. So though, usually our payloads have a lot of good science objectives behind them, what's also interesting here, and this is a theme we'll talk about in the next couple charts, is there's a lot of forward-looking pathfinder opportunity here with Hermes and these other payloads to think about, once we do these Mars missions, we need to think about what is that Earth independent capability for space weather. Right now, all of our measurements are very focused on Earth for very good reason. But once we go to Mars, we're going to lose a lot of that capability and need to be able to do a lot of these things on board. And that's part of what we start to unpack with Hermes and these other two payloads. Next chart, please. And as I think Najud was talking through earlier in the day, and likely you've seen some press and seen some of these documents, the Moon and Mars strategy, as well as the Moon and Mars architecture documents, are now public and have been released. It's a lot of hard work by everyone in the agency and a lot of good collaboration outside of the agency to get those documents done. We talk a lot about the goals and the objectives. What I'm highlighting here are the heliophysics science one, so one goal with four sub-objectives there. That first one really talks to that point from the last chart about, how do we really improve that ability to predict space weather, make sure in particular focused on how do we protect our crew as they get out into space. What's interesting on the space weather, and I think it really kind of highlights what Nikki Fox was talking about kicking off the meeting this morning, is, there's exploration can really enable a lot of good science, the Hermes payload being able to put on this platform that we wouldn't be able to make these measurements otherwise. But there's also a really important part of the science enabling the exploration, and that's exactly where the space weather work comes into play as well. I think we can jump to the next chart, please. And then a step back looking towards Artemis 1 and to highlight some really important work going on within the Science Mission Directorate, in particular with our Moon to Mars Space Weather Analysis Office. This team is out at NASA Goddard, and their intent is really to support NASA SRAG, or the Space Radiation Analysis Group at Johnson, and NOAA SWPC, or the Space Weather Prediction Center. I noticed a spelling error there. That is Prediction Center. These three groups working together provide that analysis and forecasting capability to protect crew for these human missions out into deep space, in particular, being able to characterize our space radiation environment. So our Moon to Mars Space Weather Analysis Group for Artemis 1, these three groups work together through that 25.5 day mission, doing exactly what they would do if there was crew on board, monitoring the sun, providing multiple updates throughout the day to kind of give situational awareness, just like we would here on Earth of terrestrial weather, the same type of situational awareness that you would have in those kind of situations. Understand, had we had an event during that mission, exactly what would be the posture of the crew at that point, and walking through those steps, using this as a test case. Right after that mission, actually in January of this year, those three teams got together to do a hot wash and understand exactly what went well, what didn't go well, and what can we improve for the next time. They are in that process right now preparing for Artemis 2. We will do the same exercise there, obviously with crew on board this time. So using those good lessons of Artemis 1 to be better prepared and better implement the strategy going into Artemis 2 and beyond. Next chart, please. And then a look ahead, I think Joel mentioned the decadals. I'm sure pretty much everyone on these calls are pretty familiar with those. Really a cornerstone of all the work we do across the Science Mission Directorate. We're actually in the process now of the next Heliophysics one, expecting a release next year. Part of this decadal survey, it's up to the committee to kind of push forward on different topics and provide recommendations on those. We have provided them a lot of materials relative to Artemis and the Moon and Mars effort, and providing them some questions of things that we think we really need to be unpacking moving forward for them to unpack and help us understand exactly what that path forward could be from the community perspective. So we do anticipate learning a lot from that decadal and then understanding exactly how we will implement some of those recommendations. It all kind of takes us back to this idea that I mentioned early on or brought up a couple times here is really, I think a lot of the work we're thinking about here within the heliophysics division, particularly for human exploration, is what is that Earth independent space weather capability for deep space exploration? Once we send crews to Mars, how can they make those measurements? How can they analyze those measurements to provide them a forecast and know what to do in that worst case scenario where they were to encounter an eruptive event that was going to impact them on their way to Mars? And I think with that, the next chart is just an email. If you have questions or thoughts or clever ideas, definitely let us know and look forward to the conversation continuing on. Thank you, Kelsey.